Okay, we're going to take a look at problems 4 through 7 on the PSAT practice test 1. And let's start with number 4. So this is number 4, and you see we've got this triangle, and then below we see that it's cut into these smaller triangles. You could probably guess that these are similar or proportional triangles. But here's notice. It says figure not drawn to scale. We're going to ignore that, and let's assume that this figure was drawn to scale, and let's do the problem. So it says ABC is isosceles, AB equals AC, BC equals 48. So from here to here is 48. Let's write that down. Okay. The ratio of DE to DF is 5 to 7. Here's DE, here's DF. DE was 5 to 7. Now, that's a ratio, which means we've got 12 parts. 5 of those parts are, would be, E to D would make up 5 of those parts. D to F would be 7 of those parts. So we could do this a mathy way. I'm not going to do it a mathy way. Well, here's what we do know. DF is bigger, which means DC is bigger. We know that this whole thing across is 48. What if we can see this is a little bit longer? This line here is longer than that line there. What if we found the middle of it? It'd be like right around there. What would half of 48 be? 24. You don't even need a calculator for that, which is good because this is no calculator section. Let's look at the answers. 12, 20, 24, and 28. There's only one thing that's bigger than 24. It says, what is the length of DC? DC. That has to be more than 24 because that was half. And the answer we would choose just by looking at it and figuring out that half of it was 24 was 28. And we could do that in about maybe 30 seconds and save ourselves some time. And that's going to be your best bet most of the time. All right, let's look at question number 5. This is another system of equations. They come up all the time. In a certain game, a player can solve easy or hard puzzles. A player earns 30 points for solving an easy puzzle, 60 points for solving a hard puzzle. Tina solved a total of 50 puzzles playing this game, earning 1,950 points in all. How many hard puzzles did Tina solve? You got to do a lot of these to start recognizing, look, this is a system of equations. Here's what we see. We've got easy and we've got hard. I'm going to call that E and H. And if we did, it says Tina solved a total of 50 puzzles. We got easy puzzles, we got hard puzzles, but if we add up E and H, we get 50. There's a total of 50 puzzles. We don't know how many easy, we don't know how many hard, but we know that if we add them all up, we get 50. You have to see that. You get 30 points for an easy one. So 30 points times every easy question. 30 points times every easy question. 30E plus 50 points, or I'm sorry, 60 points for every hard one. 60 times every hard one gives you the total number of points, 1,950. I'm not even going to do the math there. That's all you had to do. Once you actually figured this out, the math is pretty easy. I'll do it. So to me, I'm going to take my own advice. See, we have an E by itself and an H by itself. There's nothing multiplying these things. Therefore, E plus H equals 50. Let's subtract H from both sides. H minus H cancels. So that means E equals 50 minus H. Think of that instead of E equals 50 minus H. E is 50 minus H. E is 50 minus H, which means this E is also 50 minus H. So we can substitute. When it's easy to get a letter by itself, a variable by itself, we substitute. So we can take 50 minus h, since e is 50 minus h, and we can make that e 50 minus h. So instead of 30e plus 60h, we're going to say 30 times 50 minus h. See, we change that e to that because e is that. So 30 times 50 minus h plus 60h equals 1,950. 30 times 50 is, I think, 1,500 minus 30h. We just distributed that. 30 times 50, 30 times negative h, plus 60h. Notice we have nothing but h's now. When we have two variables, e plus h, we cannot solve. We need all one variable, 30h, 60h. Now that we can do, equals 1,950. We now subtract 1,500 from both sides, and that's going to give us 450. And negative 30h plus 60h is 30h. 30h equals 450. Let's get rid of the 0. 3 goes into 45 15 times, so h equals 15. You can do the work. It's in how many hard puzzles? Well, h was hard. There's our choice. Moving right along. This is factoring. It said 2x squared plus 7x minus 15 equals 0. We've got to break this apart. We've got to factor it. So 2x squared. We know that the front part of this is going to be 2x times x. What we don't know is what's going to be added or subtracted. I'm just going to get to this. Here's what we do know. The last number is going to have to be something that multiplies to 15. What could that be? Not many things. 5 and 3 or 15 and 1. Let's just go out on a limb and say it's going to be 5 and 3. And one of them, since it's negative, these two numbers have to multiply and add up to 15, or sorry, multiply to 15, and one has to be positive, one has to be negative to give us a negative result. Let's try minus 5 and plus 3. That was probably a bad guess, wasn't it? Because the middle one is plus 7x. So the positive thing probably should have been bigger than the negative thing. And we would find out that, yeah, that didn't work. What if we did 2x minus 3, x plus 5. Let's just see that. 2x times x, 2x squared. 2x times 5 is 10x. Negative 3 times x is negative 3x. Remember, you put these two together. 2x squared plus 7x minus 15. Yes, this was how you solve that. So 2x minus 3 times x plus 5 equals 0. And then we shouldn't be too far away from figuring out that B was the answer. And finally, number 7. I call this, from economics, a break-even point. We've got Alan and Taylor cutting lawns. And try to do less math and think, what's it going to be like? So he charges a fee of Alan charges a fee of $15 for his equipment, and $8.50 per hour. So $8.50 per hour. Every additional hour, it's another $8.50. Taylor charges $12 for his equipment. A little bit less for the equipment, but $9.25 per hour. So Taylor charges more per hour, but less for the initial rental charge. If X represents the number of hours spent cutting a lawn, what are all the values of X for which Taylor's total charge is greater than Alan's total charge? Well, here's the thing. Is Taylor going to be more expensive early on or further along? Well, the initial charge is $12, so Taylor is going to be cheaper right away, but the more hours that go by, he's charging more than Alan. So as time goes by, eventually Taylor's going to be more expensive. So when is Taylor's total charge greater than Alan's total charge? Well, hours are going to have to be bigger. these two don't make any sense. There's no reason why for a little while it says 3 is less than x is less than 4, less than or greater than. So why would at one point Taylor be more but then eventually be less? Neither of these two make any sense. Which of these two? Should the hours be low, less than 3, or should they be big, bigger than 4? Without even doing the math, we know that as time goes by, Taylor's going to eventually be more expensive. We want the big number. It's A. We didn't even have to do the math. If we did do the math, though, by the way, $15, it would have been $8.50 per hour, and X was the hour. So 8.50 times X plus 15, and I would just set these equal to $9.25 X plus 12. And now we do regular math problem. Subtract 12 from both sides, and we get 3. And then 850, we subtract that. 850x minus 850x. That eliminates, and we get 3 equals 0.75x, I think. So anyway, and then you could solve what x would have been. Bottom line, as time went by, Taylor was going to be more expensive. It was A.